Okay, so we're going to now move into post-processing, and the first thing that we need to do is prepare those RGB masters that we just created for combination. And so you'll see, if you recall, there was some black bars on some of the images that we'll need to crop them. We'll do a linear fit to make sure that they're all of the same brightness levels, and then I will do background extraction. I think I'm going to skip background extraction and do that once I have combined. But there is no right or wrong. I think it depends on the data set that you're working with, whether or not you do that before, after combination, or maybe even both. But let's focus on preparing for combination. So I will close that up, and let's first see which frame, if any, has more of a black border, because we want to take the worst image and crop it, and then crop every other image to that same level of cropping. If I just zoom out on any one of these, there is just an ever so slight black border. I think we saw it on the blue, if I recall. It is very minor, and that's because basically I had captured all this data in one night. I didn't have to do a meridian flip, and so the tracking, other than the dithering that I did, was pretty good. So there's not a lot of shifting up, down, left, right that it had to do to align these images. Nevertheless, I am going to still crop an ever so slight amount of the edges off, just so that there's no question that there is no black bars on the edges. So I will open up the crop process. This is a dynamic process, meaning you can only have this one running. You can't be applying this and then run any other process at the same time. And you can see it already activated the image that was highlighted at the time. And so I will just slightly move the cropping zone in from each edge, just ever so slightly, because I don't want to throw away too much of the image. And that's it. Before I apply this, however, though, I want to crop each and every single frame the exact same way, so that when we stack them on top of each other, they are pixel for pixel the exact same size image. And so before I apply this, hit the green check, I want to save this as an instance on my desktop, so that I can apply it to the other ones right away. So I will hit the green check now, and that's it. It did it. It cropped the image, and so I will tuck him away for now. And then now that I'm done with this process, I can close it. And now the whole point of why we saved it to our desktop is now I can just drag that process. I don't even have to open it. It will apply that same cropping settings to the blue frame, and then similarly to the red frame. And so now I can minimize those and tuck those guys away. The other thing that I want to do is make sure they're of the same brightness level. Now, it appears that, because this was such a dark site that I took this from, there wasn't any moon, there wasn't much going on, which is a good thing, that this data is pretty good. Those frames are pretty flat as it is. It's maybe a little bit brighter on the bottom side than the top for some of these frames. So I could do linear fit, and I could do background extraction to them before I combine them. I'm going to try and do it after, but I will do linear fit right now. And it's really somewhat subjective. Sometimes it's more obvious than others, especially if you have like H-alpha data is usually very bright compared to your RGB data. Because this is all I have is RGB, they're all very similar. But I did notice that this star, this big bright star that's in the frame, for green and red, is fairly similar, but then when you get to blue, there seems to be a lot more luminosity around it, which is maybe something you want to preserve or keep. But in my case, I kind of want to tone it down a little bit. So what I'm going to do is I'm going to leverage the red frame, which seems to be the least amount of luminosity around that star, and use that as my baseline. And I'm going to linear fit the blue and the green to be the same as the red. And so I can tuck the red away because I'm not going to apply this process to it. I'm going to reference that one. And I'm going to go to Process, Linear Fit. My reference image is the red, which we just talked about. And it's not going to look like it did much. It will, because the screen stretch is going to get messed up. But when I apply the stretch, it'll go back to what it looked like, and it will be hard to tell, but trust me that it did indeed do something. And then I'm going to just restretch these images because now they've been changed. I'm going to unlink them and restretch. And now they are now linear fit to the red frame. All right, so now we are ready to combine them. In this case, I'm just going to use channel combination because it's a straightforward RGB image. Now, because we called these frames Master R, Master G, Master B, PixInsight is smart enough to guess which of your images that are open should be assigned to the red, the green, the blue image. So when I click this little icon, it automatically guesses red, which is correct. So I'll just say OK. Same thing with green. It guesses correctly. And then blue. It guesses correctly. If it didn't, you just choose the right one from the drop down. And so color space is RGB. Hit the circle, and it now just created your color image. So I can close this process. I'm still going to leave the channels unlinked for right now. The red, green, blue unlinked so that it stretches them each individually. And this is our first glimpse of the color image, which seems doesn't there's color there, but it just doesn't seem very rich or very saturated at this point. And hopefully we'll try to draw some of that out. Okay, so following our process here, we have prepared the images by cropping them, linear fit. We've combined them, and now I think I want to do background extraction to see if there is it's slight. It's very, very subtle, the amount of gradient that is in this image, but it does maybe appear that the bottom half is slightly brighter than the upper half. And so I'm going to use DBE, Dynamic Background Extraction, to address that gradient, because we want this to be as flat of an image as possible. So some of the settings for DBE that I use, because this is a galaxy, there's not a lot of nebulosity, if any, other than around the galaxies present. When I'm going to define the sample points, which are what I'm going to call background sky, I am very, very confident that what I'm defining as background sky is indeed background sky. So I can raise the tolerance up pretty high. I'm just going to choose 5, and I'm going to leave these other settings: shadows relaxation at 3, smoothing at 1/4 for now. The default sample radius, that's how big of a sample point do you want to generate. 25 seems appropriate right now. If that needs to be reduced, I can always change that. And then I'm just going to do 7 samples per row. Maybe that's a little too much. You'll see here in a second it's going to generate several samples. More is not always better. You don't need a ton of samples, but I like to use the generate in this case. The rest of these settings, of course, this is background extraction, so I'm going to use the division. I am going to normalize. Right now, I'm going to keep the background model, because we'll look at that in a second. And for right now, while I'm testing the settings, I don't want it to replace the target image at this point. I want it to generate a new image. So I'll uncheck that for right now. We'll apply that later. And let's just see what it does. So let's generate those sample points. And I want to make sure and go around on each and every single sample point. That's why another reason why more is not always better, because it means more work. But I'll go through each and every one of these to make sure that it's not on a star. I want it to actually be only specifying background sky. And so you can see just ever so slightly, this one is clipping a star. So I'm going to nudge that one just by selecting it and moving it. And now it's back to just sky. And so you have to go around to each and every one of these just by clicking them, making sure that it is indeed not on a star. So that one's just on a star a little bit. So I'm just going to move him down away from it. The rest of these, the other thing you want to do is stay away from the galaxy region. And if you were doing an image with nebulosity, you certainly want to stay away from nebulous regions, because those are certainly not true sky background. So I will go through this. I'll pause the video and then come back in a second. Okay, I've gone through all the sample points and made sure that they were not on top of any stars. And any of these, in fact, I'm looking at it, even these right here are kind of close to this galaxy, the glow of the galaxy that's happening there. So I'm going to move those away, because I don't want it to think that that glow is what is defined as just regular background. And this one, we'll just move him a little further away. Same thing here, to make sure that they're not confusing background with what is a galaxy glow. All right, so I'm happy with the placement of these. Let's see what happens if I just generate a image with the background gradient removed. So the first thing it does is, because I chose to keep the background and show me what it did, this is the background gradient that it removed. And so if I stretch that, it looks like this funky psychedelic color thing. If you have these icons that are loaded up here for smoothing, you can just hit this 24 and it makes it a little bit more smooth to kind of generalize what the gradient that it removed. And so now I did think that it was a little bit lighter on the bottom and a little bit more darker at the top. I mentioned that. I didn't necessarily see this greenish glow and this reddish, but let's take a look and look at the final image and see if it did all right. To me, this looks like a very fine image, very flat image. I don't see any excessive gradient removal that I can tell. One thing you can also do is stretch the image to an extreme, just to exaggerate some of those. And that will help also show whether or not there's some, oops. So that looks like a pretty flat image there. And it's equally blowing out all of the channels together. I don't see anything that is abnormal in this data. So I will go with that. But now remember, I didn't apply that to the actual image. I just created a separate image. To preserve the history on this, I want to make sure that I apply it to the image. So I'm going to now discard the background model because I don't need to see it again. And I want to replace the target image, this image that I'm working on. So I hit the green check, and it will apply it. And then once that's done, I can close out of that process. One thing I forgot to do is when I combined my image, my red, green, blue, I typically rename this. And so I will now call it my RGB image. So So I should have done that before. All right, so we've let's take a look at the history. If you right click the tab and you say load history explorer, it will pop out and you can see that we generated the RGB image, we did dynamic background extraction, and then we renamed the file to be RGB, and that's where we currently are. So if you're ever wondering where you are in the process, that's why I want to try to apply everything to this image. Then it preserves the history in the background, and I can always go back in time too. So that's a powerful feature in PixInsight as well. Okay, so next step is to neutralize the background. Before we do that, we need to specify a small preview of the background sky. And so it doesn't really matter where you choose it, it just needs to be definitely background sky, and it could be fairly small. Even smaller than this, but I'll choose this because I'm able to fit this box in there. And if I just jump on that little preview, you can see it's actually there is a little tiny star there, but it's not going to hurt it too much. But this is a really good sampling of what the sky background looks like, and that's what I want. I want to define what a good sample of background sky looks like. Because when I do now background neutralization, which is this icon here, my reference image, what is the reference image for background? Well, it's that preview that I just created. So I wanted my RGB preview 01. Hit OK. And these settings that I have here, I will leave and just apply to the image. And again, it won't look like it did too much when I re-stretch. But now you can start to see that there's a little bit more color coming out. As opposed to when we first started out, and so it's balancing the red, the green, the blue channels more to have this color come out. One last thing is color calibration. For white reference, I'm just going to maintain the target image. You know, some people will specify the center of the galaxy. Or to the center of this star, for example, and maybe I'll try that here depending on how this turns out. But right now I'm just going to use the target image as the white reference, and then for that background image, I'm going to still again call up that same preview that we just created, RGB preview 1, and let's just see what it looks like. Let's see if a lot of times you can't even detect that it did anything. And so yes, it did. It made it a little bit whiter again, but that's calibrating the color. Let's see if I like that. So a lot of this is trial and error, and I tend to like these galaxies a little bit more yellowish, like it was. So what I'm going to do is I'm going to save a copy of this. Okay, and just use it because I'm going to blink them in a minute here. I'm going to undo that to my original image, and instead of using target reference as the white reference, now I'm going to actually specify a white point on the image with a preview. So I'm going to choose this really, really bright star in the lower right-hand corner as my white reference. I'm going to create another preview ever so slightly, and then I'm going to select that preview 2, and let's see what happens. Let's see if this does any better. Now that looks subtle to me. That looks like when I'm blinking, these are going to be virtually the same. So let's take a look. So this was the white reference set as the target image, and now I will blink them. Boy, I don't see any difference whether I use target reference or target image as the reference, white reference, or if I specified it. Let me zoom in to say this galaxy here, and I will match this same zoom level to the other one and blink them again and see if you can see the difference. I see virtually no difference at all. So whether you specify the white reference or not, apparently it doesn't really make much difference on this image. Perhaps it will on different images. I'm just going to stay with how we did the first time. So I'm going to undo this. I'm going to just keep target. I'm going to reset the tool. Choose my background image. Leave that alone. Apply it and go. All right, so we have color calibrated. The next step is where we have to go on a little bit of a divergence, because now we're going to get into deconvolution, and there's several things that you need to do in preparation of deconvolution. And the other thing that is, we typically do not apply deconvolution to a color image. We apply that to a luminance image. Well, I didn't capture any luminance data, but I can extract the luminance data from this color image and work on it, and then re-add that luminance back once I've edited it. So we're going to do that in the next segment here, but I'll end for now. Just to recap where we are in the process is we have prepared for combination, we have combined the data, and we've already started image enhancement. We've done some color balancing, and now we're into deconvolution. Once we complete that, we will perform some noise reduction, and we will then permanently stretch our images prior to recombining that luminance data back into the color data. All right, so that's next.